Hello, Mario. Land Surveying 1, Session 6, Calibration and Error. Hello, welcome. In this video, or this session, we're going to take a look at calibration and error. Error is an essential part of surveying, and managing the error is a key component of good survey practice. So let's go to the large screen and work our way through the PowerPoint for this session. So here we are, here's our title page, and then we look at our plan, our session plan for the session. And as usual, we will have a 2-hour tutorial where I'll take a note of who's there, hand out some session documents, which we will have a look at in due course, and then go through this introductory PowerPoint. And then that's the rest of the time that's available will be used for work on topic tasks, catch up with your teammates and what have you. Then we will have a 4-hour practical during the course of this session or the week, which will follow again a similar pattern of we go out into the field, complete our health and safety documentation, undertake some practical tasks, and then the session ends. So, moving right along, the key learning outcomes for this session are that on successful completion of this session, you should have examined the difference between calibration and verification. What is this difference? And this is key. Calibration is where we make sure, or we adjust our instrument or measuring equipment so that it measures as close as possible to correct as we can get it. Verification is where we use or check our measuring equipment against a known standard so that we check that it is calibrated correctly. You've looked at rounding in the context of land surveying. In land surveying, we don't go down with so much with the mathematical niceties of stating the number of decimal places after something or how many significant figures. However, it is assumed that if something is shown to 2 significant figures or 2 decimal places or whatever, that is an indication of its accuracy. So if, say for instance, something is shown to 3 decimal places of a metre, one would assume that it's been measured to the nearest millimetre. If something is shown to the nearest 2 decimal places of a metre, to the nearest centimetre. If something is just stated to the nearest metre, we would accept that that is the accuracy. So the rounding is indicative of the accuracy. You will have worked in degrees, minutes and seconds. Just like time, degrees are divided into minutes and seconds, as are hours divided into minutes and seconds. The two are very much related when one looks at the interaction between longitude, which is typically measured in degrees, minutes and seconds, but also in hours as well, because we know that, like for instance, New Zealand during the when it's not in summertime and daylight saving time is typically set to be 12 hours ahead of Greenwich Mean Time, which is 180 degrees, half the world away. You will have closed a traverse with calculations, set up and used a total station, measured angles and distances with a total station, and calculated distances and bearings between survey marks. So quite a lot to do now in this particular session. So the simple survey concept that we're going to look at in this session is what are 5 ways 5 ways of fixing a third unknown point from 2 known points. So if we see here, P and Q are 2 known points and we know the distance between them. And typically in surveying we also have an idea of the direction that would Q to P would be going from south to north and P to Q from north to south, following the convention that north is generally up the page. So how do we find the unique position of R? And in this instance we're just talking in X and Y, although Z could be in it as well, but not specifically in this example. So first of all you could measure the distance P to R, and then you could measure the distance D to R, Q to R. Now knowing those distances, you would have 2 sides of a triangle, all 3 sides of a triangle, known lengths, and that would be sufficient to be able to determine the unique position of R. So that's the first one, and that's sort of related to what we might call trilateration, where you're using a distance. Now the second one, again you know P to Q, and again you want to find the unique position of R. What is the minimum information that you need, different to what you've got here? Well, you could find where a perpendicular between S and R, you could find out what that perpendicular distance between S and R is. And that would be the smallest distance between S and R. Any other distance that wasn't perpendicular would be greater than the perpendicular distance. Okay, and then you could measure D, the distance from Q to S, and that would enable you to find the unique position of R. Here's the third example here, and in this one you could measure the distance Q to R and the angle, and again that would be sufficient for you to be able to come up with the unique position of R. So this one here, the second one, is generally called offset. This one here we typically in surveying we call that sort of radiation, loosely. The fourth one here, you could measure the angle, QPR, and you could measure the angle PQR, and that would be sufficient information to enable you, because we would have the distance and 2 angles, to enable you to find the unique position of R. This method is typically called triangulation, or using triangles really. And then finally there is one third method, and that is where you perhaps find the distance P to R and the angle PQR, and putting those together, that's a bit of a hybrid solution there. Now these methods are somewhat redundant in a sense these days, where we have total stations that can measure the angle and the distance. But in previous to the total stations, when we had to actually physically measure distance with tapes and things like that, sometimes some options were not possible because of the constraints of the terrain. It was just too rough or covered in gorse or something like that. But with the total stations, where you can just do things by line of sight, some of these options, particularly the options where you're measuring the angle but not the distance, are a little unrealistic, as we are able to now measure both angle and distance. And sometimes reflectorless, what we call reflectorless, where we don't even need to put anything at R. We can just look at it and point to where we want to measure, and that will enable us to find out the distance. So there are 5 ways that we can find, or the 5 ways showing the minimum amount of information in each way that we can locate the unique position or coordinate of R. Alright, So now moving on to some public service announcements. Is your diary up to date? Is your diary up to date? Now would be a good time just to perhaps make sure your diary is up to date in the 2-hour tutorial, typically when I show this video or perform the presentation that I'm doing now live. Might be a good time just to check your diaries up to date, fill in what you've done for the week perhaps. Although I must say, ideally the best time to fill in your diary is at the time that you do the work. Now, coming up soon is the assignment 1, the levelling assignment is due soon. And you should check the date when that is due and make sure you're on the burn down path to having the levelling assignment completed and into your tutor before 11:59 p.m. on the due date. So make sure you're on track with your levelling assignment. Also coming up soon will be a levelling test. After the assignment, it's coming up. Check the date for this. It's usually held during the tutorial, the 2-hour tutorial. Typically, you will come in, spend a little bit of time just preparing for the test or checking a few things out, and then we will, round about half an hour after the start date of the tutorial, the exam will start with 5 minutes reading time, or the test 1, 5 minutes reading time, followed by 1 hour for the test. So be getting ready for that by studying the parallel test, which I've made available in this unit, and the other available tests. There's no reason why you shouldn't do well in this test, and certainly there should be nothing in the test that is of any great surprise to you. It's all of the questions mostly have been asked before and hence answered. So just remember here the 5 simple survey concept, 5 ways of fixing a third unknown point from 2 known points. This is the simple survey concept of this session. So let's just quickly go through them. Here we go. 2 distances. Here we go. The line and offset at right angles. Quite a handy and useful one for measuring irregular boundaries. This one here, which we're measuring a radiation, or a bearing and distance, or an angle and distance. Bearings are typically an angle measured clockwise from north. Okay, and then this 4th one here, where you've got 2 angles off the 2 known points. That will typically is recalled triangulation. And finally, a hybrid solution where you're measuring a distance from one point and an angle from another. So 5 ways of finding the unique position of an unknown point from 2 known points. All right, and that brings us to the end of the PowerPoint. What's new in Moodle? Well, there's only one way to find that out. So let's go and have a look at Moodle Land Surveying. I have been getting a little bit of feedback regarding the course outline and the fact that I had some of the dates and things wrong for the 2017 tests and things. So I've updated those. Hopefully that will now be okay with people. So what I've done is I changed the levelling assignment there into week 14, which coincides with when it was due. This is for the 2017 year. So if you're watching this in 2018 or 19 or 20, these dates might be a little bit different, but it should still be around about that week. at best it will be in the course outline. So I have adjusted these because some of the feedback I was getting that this was a little bit confusing. So there we go. So we'll just close out of there. So that's pretty much all to report there. I guess we should have a look at assessment for 2017. Remember that this will be different, but the assessment, when the assessment's due, is under the assessment lab. So under the assessment tab up the top here. So when we see the course diary there, remember that that's an ongoing assessment, and then we have the leveling a test, a leveling assignment. Okay, that's the assignment due on the 3rd of April. Now, I refrain from giving you exact student examples of the leveling report and what's due there, because it's really up to you to do some of the thinking along the line, some of your own thinking on this. I can show you examples, but only show you examples. I can't physically or digitally give you an example. The traversing assignment is coming up, and we've got a date for that. And then the leveling tests are down here, and we've got a test coming up on the 12th of, in 2017, it's coming up on the 12th of April. And so here's some examples of tests, a series of examples of previous tests going back as far as 2014, and including a little generic test there. So quite a few tests to use as examples in your for your study and studying for the test. And as I said, there are no surprises. So let's project management. Nothing to add there, though I'd like to see you managing your projects. The worksheets here and the answers, and some resources here, obviously relevant resources that might be so some reference notes, exam papers, parallax, some notes on leveling, GPS teamwork, flip teaching, spreadsheet for the leveling field note here, that's helpful. The Excel spreadsheet, one of the most powerful programs that you will use in its universality. I had an example today. If you are sitting in front of your Excel spreadsheet with a calculator keying numbers into the field, you're doing it wrong. You're doing it wrong. The spreadsheet should be doing the calculations for you. And I had occasion just this week to catch some students doing exactly that. And they had spent considerable part of their day, quite a number of hours, calculating these numbers and put them in. I was able to show them how they could have done it in about 20 minutes by using the power of the Excel spreadsheet. It was quite a revelation for them, a really good learning experience, because seriously, I don't think that they will be doing that again. They will be looking for ways to use the spreadsheet to save their time. They were quite astounded that the work could be done in such a short period of time by using the spreadsheet as it's intended to use. So let's have a look at calibration and error here, just as a bit of an overview of what's going on. So here it's coming up. So I've got the plan, the session notes, and the checklist. You'll see in here there's quite a lot of I've got quite a lot of videos and background material, and it's really worthwhile reading all of that stuff. It's mostly reading. There's not much need to take any notes or that on it, but the background and that there is really helpful, and it just fleshes out the whole topic of the idea of calibration and that sort of thing. There's also a number of videos here that are quite important for getting into the calculations. the calculations of bearings and distances and that. And again, it's probably a good idea just to watch these videos and maybe take some little notes about things that you're unfamiliar with. But other things, or just knowing they're there, is going to be quite helpful for the future. So we need to get in there. So these are some videos that I've done earlier, and they will be most helpful with some of these worksheets, which will I'm picking will be quite unfamiliar. They won't be ones that you will be familiar with. So here we are back here. So quite a lot of notes. Read through the notes, and then there's a worksheet on rounding and accuracy there, just to refresh your memory on that. Then this video here will be located in here somewhere, the introduction. Degrees, minutes and seconds, it's particularly on the FX82. A lot of people have difficulty with this. It's quite a simple concept, but one that people are not generally familiar with. So the idea of decimal degrees and then degrees in a degrees, minutes, seconds format, which is very typical of surveying. It's important that you have a good understanding of that, both for your field work and for some of your office work. And then we have some little traverse closures here, which will be quite unfamiliar with you, but these feature fairly prominently in the exams, worth quite a little bit of money, a few marks. So you do have to get these done. And then some exam questions there. A copy of a parallel leveling test, I've included that in the package of documents, so you've got a blank one of those to work away on as part of your study procedures. The practical tasks this week involve taking some measurements for bearings and distances, and again this will be the bearings and distances will be in degrees, minutes and seconds. We will have to be meaning those, and this will be unfamiliar territory for a lot of you, so you will need to pay strict attention to it, and perhaps just take some time to read up beforehand so you get a bit of an example as to what's going on. So there's a field note, example field note there from this little exercise. Note that this exercise, the example field note, is not from the where we will be working by the container at the end of G block. This is from previous years where I was based somewhere else, and so this is from there, as is the computation. Here's a Traverse sheet form for you, typical Traverse sheet form from Lands and Survey, Lands and Survey, which predates Land Information New Zealand, and even DOSLI, Department of Survey and Land Information. So quite an old spreadsheet form there, but still up to the mark, still up to it. And then there's an example. So this is the field note, and then this is the example computation or reduction of the field information. So you need to get all of that information together and put it down here into the what success looks like. So this is what your unit will look like for Unit 6, and it'll look something like this. So here it is here, Control 0. So should have a nice little tidy front page there at Unit 6, so we all know what it is, and this will be in a single PDF document. There are still a number of people that are saying they're having trouble putting things into a PDF document. Come and see me, I'll show you how to do it. I want it in one PDF document. So here we are, our man Stu has worked through and filled in as he's completed each task, did it all in a day. It's just amazing, this guy Stu, and got it all done and signed off and what have you. So that's Stu's work. So the little rounding one, yeah, this is a bit of a scenario based situation, and So I'm asking you to put a little bit of thought into this. You've been asked, someone in the neighbourhood has asked you, said, you know a bit about surveying and maths and rounding and stuff. So how would you do it? And that's an opportunity for you to express how you understand rounding and significant figures and that type of thing, how that relates to accuracy, and just put it all together to help you clarify in your own mind and your own words as to how you might go about it. Now, I've given an example here from a student, a previous student, and they've put together quite a comprehensive little sort of lesson plan, I'd say, with a bit of a video there on how in another YouTube video there. So they've put together quite a good learning sort of plan there for this teenager, and that's how what they're going to do and how they're going to go through it, and what examples and what have you they're going to use. So that's pretty comprehensive and sort of what we're looking for here. Okay, so oops, that's up. I want to go down. This is the degrees, minutes and seconds whole thing. So I've got a video I think that goes with this. So we've got degrees, minutes and seconds format on the left, and the degrees and decimals on the right. Remember to set your calculators to degrees, not radians, but degrees. Okay, and be aware that 1 degree, 60 minutes, 1 minute, 60 seconds, 1 degree, 3,600 seconds. And if you want to get the degree symbol, hold down the Alt key, Alt key, and type 248, and that'll get you the degree symbol in most situations, but not all. It depends on what fonts you're using and what programs you're using, but typically it works. Travis closure worksheet. Again, there's a video on this where it's sort of, I go through it in some detail and tell you what to do. There is no formulas on the formula sheets for this. You must remember that the cosine of the bearing will give you the north ordinate, and the sine of the bearing will give you the east ordinate, and that these have signs. They are positive and negative, and that those are important. Okay, and the adjustment for these, the Bowditch adjustment, is typically it adds on. It's different to the leveling. It's not cumulative. It's you add it to each one and then come forward. So just a little bit of different regime there to the leveling. So forget about your leveling now, what you've done in the leveling. You don't transfer that across. We're now doing traversing, so it's a whole new scenario and some slightly different ways of doing things, which you are expected to remember and learn. So this is another Travis closure, another spreadsheet closure there. And this is another one here. This is number 2. So that's number 1. Number 2, and there's your parallel test, which you can, with the answers there for you, all filled in, which you can work through. Some exam questions there relevant to this topic. Your practical tasks, firstly your field note, where you've measured it out in the field, or measured and reduced it down and got all of the everything in the reduced correctly. And then here is the field diagram with the reduced bearings and distances all shown on it. Then that information is put into a Travis spreadsheet and diagram, calculating it all out. And your health and safety documentation relevant to the day or to that whoever that should be for your group should also be included in the situation here for you. So I've put some generic health and safety documentation in here for this case here, but you should put in the one that relates to the day that you're there, because you fill out health and safety documentation every day you're out in the field. So that is pretty much all I've got to say about Moodle, and we're going to move on. So let's just go back to the back to the main screen there, and back to Maureo. And that brings us to the end of a Land Surveying 1, Session 6, Calibration and Error. So you need to do some background information about calibration and error. What's the difference? I haven't gone to any great lengths to tell you in this. It's a matter of finding the information and doing the worksheets. It comes up and it's very important. So I'm going to call it a day there, and it's all up to you. I've put the challenge in front of you. It's up to you to meet the challenge and submit in one PDF document all of the worksheets and requirements that I have alluded to in this discussion or presentation. Cheers! See you!